I mentioned in the previous lesson that we at this point have covered all of the algebra concepts that you would need to solve any kind of linear equation. And there are only certain things that can be done at this point that might make an equation harder to solve, and that might just involve adding more pieces into the equation or messing with the numbers and making the numbers harder to deal with. So this lesson is going to focus around equations involving decimals. We'll talk a little bit about what form to leave your answer in, how to use a calculator when you're dealing with decimals in the equations, and how to get rid of the decimals in the original equation if you need to. So let's take a look at our first example. So our first example is this: negative 38x minus 39 is equal to 118. And in this particular case, the directions might say something like round answer to 2 decimal places. And we're going to say a few words about that and variations on that. So this looks like a pretty ordinary equation. So we go about solving it using the methods and tools that we've already developed. So here's the x. The x is what I'm trying to get by itself. It's being multiplied by negative 38, and then we're subtracting the 39. So we want to kind of undo those things, and we'll start by adding the 39 to both sides. And this gives us negative 38x is equal to 157. And we remember that this is multiplication, and we undo multiplication with division. Make sure that you're not slipping into the habit of writing an x right here. That would not be true. X divided by x, provided x is not 0, which we don't know that it's not until we solve it, would be equal to 1. And what you'd end up doing is creating a situation with an x and a denominator on the other side. So what we have here is negative 38 over negative 38 is 1, leaving us with just the x. Now the problem here is that this does not divide evenly. So we end up with something that's not an integer. Convention in math is that you leave it as a simplified fraction. That's just kind of our go-to in the absence of any other directions. That is generally how we would leave it. But sometimes you will see directions like these over here on the right that says round your answer to 2 decimal places. And this is where you want to have a calculator. And usually by the time you're in Algebra 1, you are allowed to use a calculator for at least some things because you've gone through your elementary math where the point of the math lesson was to learn the mechanics of the calculations. Now we're learning a totally different skill. We're learning how to solve equations. We don't want to get bogged down doing like big long division problems. So you would grab your calculator at this point and you would get a decimal answer. And when it says to round to 2 decimal places, this is what it means. It means 2 digits after the decimal point. It does not mean 2 digits total. And I have seen students kind of confuse that. So 2 decimal places means 2 digits after the decimal point. And we might also want to talk a little bit about what it means to round. Rounding is one of those things that should be taught in elementary school, and I think it is, but it comes up. Let's talk about how we round, what the rules for rounding are, and then other ways that you might see a direction like this posited to you. So rounding. You are usually told where to round to. If you're not, it's a question you might want to ask your teacher. Like, am I rounding to 1 decimal place, 2 decimal places, 3, so forth, rounding to the nearest 10, the nearest 100. The way that we round is we always look 1 digit to the right. Look 1 digit to the right of the spot where we want to round to, of where we round to. I don't know if you can hear my cat. I don't know what his problem is. He's making a lot of noise though. So let's say you have 2.134 and you are asked to round to 2 decimal places. Well, you would look 1 digit to the right. which in this case is a 4. If that digit is less than 5, we round down, which in this case means we would go down to 2.13. If the digit is greater than or equal to 5, we round up. So let's see, we'll look at an example of that. So if you had 2.136, we're again looking at that one digit to the right, and so that's going to bump this up to 2.14. And just so you can see what we're doing there, because I've seen some like really strange mistakes with this. So let's say you've got like 2.13 and then like 2.14, okay? And then in between them, what do we have on that first one? 2.134. So 2.134 would be like right about there, 2.134. And if you look at it like on the number line, and that number line is so important. I know I mentioned that earlier when adding integers, but the number line really does give us that picture. So what we have going on here is 2.134 is closer to 2.13 than it is to 2.14. And that's really all rounding is. It's a matter of kicking it to the closest value that's to the correct, decimal place that we're going to round to. So, but 2.136 is just a little bit further to the right, and so 2.136 is closer to the 2.14 than it is to 2.13. And of course, right smack in the middle, you have 2.135, if my pad will let me write it. There we go. And so that there really isn't, like it's not closer to one or the other, and the convention is that you round that up. There are some variations on what to do with the 5, but we're not going to worry about that now. So for Algebra 1 purposes, the convention is to round up. Now, the couple mistakes that students make, one is kicking it down too far. So if you're rounding down, you're not going down to 2.12. Okay, don't do that. Down is going to the left, so it's 2.13. It's kind of like truncating the decimal. The other thing that I will sometimes see students do is if they have like 2.1347 and they have to round to 2 decimal places. Well, you only look one digit to the right. Only one digit. So you're only going to look at the 4, which means that this is going to round down to 2.13. What I have seen some students do is they look a little bit too far and they'll say, oh, but there's a 7. So the 7 is going to round the 4 up to a 5, and then the 5 is going to round it. Don't do that. Don't chain your rounding. It's just one digit. That's as far as you look. So that I wanted to make sure that we covered, just because I see so many mistakes with rounding. The other thing we want to know is the other way that you can see those directions. Now, it's really nice when it says round to two decimal places, but it often will be written like this. And so the directions might give that thousandths, the actual terminology for the place value. So tenths is the same as 1 decimal place. Hundredths is another way of saying 2 decimal places, and thousandths is another way of saying 3 decimal places. It would be rare that like you'd be asked to round to 4 decimal places. It would be like a very specific kind of problem where you needed that much accuracy in your numbers. So just make sure that you're paying attention to that in the directions and know how to interpret that vocabulary, because you don't want to get a problem wrong because you misunderstand what the directions on the rounding are asking you to do. Those are common mistakes that I see. All right, let's take a look at another example. So this, say we have a 3.57x minus 37.40 equals 0.23x plus 8.32. And I tell my students this all the time, that math is really consistent, and I've probably said it in these videos a bunch. Math is really consistent. Once you learn the rules that govern how the algebra works, those rules don't come in and go out, and it's not like the English language where there's a million exceptions to the rules that we have. Math is really, really consistent. So the way you isolate an x in this equation is exactly algebraically the same as what we were doing in the last lesson. The only thing that's different is that the numbers out in front look different. So in this case, we have x's on both sides. Over here, I have 3.57x. Over here, I have 0.23x. And just to let's just say it was integers, okay? I'm going to erase that in a second. Don't write that down if you're taking notes. If you were doing this, you would subtract your 1x from both sides. Like if all of these were integers. I don't know why I copied that as a decimal, but so the algebra is still the same. If we want to isolate that x, we're going to subtract. That algebra step, if you look at these two algebra steps, they're exactly the same. The only thing that's different is that this problem is using integers and this problem is using decimal numbers instead. So that's what we have going on there. 3.57 minus, what is this? 3.34x minus 37.40. Of course, 0.23 minus 0.23 is 0. So that's why that cancels out. You never want to lose sight of that. Here I'm subtracting. So I undo subtraction with addition. All of this algebra works exactly the same way. Now I have 3.34x. These add up to 0, which is fantastic. And we end up with, what do we end up with? 45.72. And then this is multiplication, and we undo multiplication with division. So nothing at all changes in our algebra. The difference being here that when you divide it, you're probably going to grab a calculator. Okay, that's not a problem that in an algebra class we want to spend a long time grinding out there. Hopefully you can, but I mean, nobody on the planet wants to. All right. Now the directions on this I'm trying to look at the problem. Okay, it says round to 2 decimal places. So let's go take a look at the 2 decimal places. I could have made that up. So there's my 2 decimal places. We look 1 digit to the right. That digit is greater than 5, so, or greater than 4. And so that's going to take this 8 right here and round that 8 up to a 9. So 13.69. If you were to check this answer by plugging it back into the equation, you would get numbers that were really close, but not exactly the same. So and that's because of the rounding error. So when we do rounding, we're kicking out part of that number there. So if you were to take 13.69 and plug it back into the original equation, you would get 2 numbers that were very, very close together, but not identical. They would not be exactly the same. And that's acceptable as long as you understand where that comes from and why that's the case. Like, that is because of the rounding. And it's one of the reasons why a lot of mathematicians don't like using decimals and they prefer to keep those fractions in there. Last topic in this lesson that I want to go over is getting rid of the decimals in an equation in the first place. And this is one of those things. Some people will opt to do it. Some people won't. It's really a personal preference sort of thing. But if I look at this equation here, notice that there's 1 digit to the right of the decimal point in all of those. And I don't want to go back and rehash, 5th grade math or whatever, where you multiply by tens or powers of 10. But if you multiply 4.5, we'll just do the 4.5, and you multiply that by 10, you get 0, 0, so 0, and then we do 5, and then 4, like so. And then you look to count up your decimal places, so there's 1 digit to the right, and so that ends up being 45. Okay, and essentially multiplying that by the number 10 gets rid of the decimal point. Now we know enough about this, this symbol right here, okay, that we know we have to be really careful. We cannot just take 4.5 and change it to a 45 because then the two sides of the equation would not be the same. But we can invoke that golden rule of math. And the golden rule of math is whatever you do to one side, do to the other side. So I'm going to take this whole left side here, the whole thing, and I'm going to multiply that whole thing by 10, which means I have to be consistent and take the whole right side and multiply the right side by 10. As long as I do the same thing to both sides of that equation, then I know that my equation stays balanced, and pretty much what you're going to get is an equivalent equation that looks different. Now, I just did the example out where if you do 10 times 4.5, that is going to move the decimal point one spot to the right, giving you that 45. I could redo that same example with all of these numbers, but math is consistent. It's awesome. So if multiplying by 10 moved the decimal point one spot to the right, when I multiplied 4.5 by it, it's going to do the same thing with the 7.2. And it's going to give me 72x. Over here, it's going to move the decimal point one spot to the right. And so we'll have 34x. And once again, one spot to the right is going to give us 495. Now, what we've done in doing that step is we've successfully gotten rid of the decimals in that problem so that we can work with integers instead. Whether or not you want to do that, or whether you prefer to do something like this where you just work the problem out with the decimals, is really up to you. It's just one of those things that's an option out there if you don't want to work with the decimals. Sorry, I apologize about my cat there. Let's go ahead and isolate our variables. So I have negative 72x on the left. I'm going to add 72x to both sides. These cancel out, leaving me with 45. This ends up being 106x plus 495. We'll subtract the 495. And remember, you are welcome to not show that. 45 minus 495, and I copied the problem wrong. Hang on a second. Is negative 450. And then we divide both sides by 106. And I actually don't even have my phone in the room where I'm recording this, so I'm going to leave it right there and trust that you can divide that out on a calculator if that's what you wanted to do. So that pretty much wraps up this lesson. It is important to know how to work with equations that have decimals because so many of the real life numbers where you might be applying your algebra would have decimals. Anything involving money is going to have decimals. Anything that involves finding the percent of an integer will likely involve a decimal. And we know that the real world isn't just full of integers, that it's possible that if you're riding your bicycle, you could be going 5.3 miles per hour. That would be pretty slow on a bicycle, but you get the idea that real life numbers are messier. So I'm going to put a couple of practice problems up. Again, there's not really any new skills in this section. So I'll just put a few up there so you can practice the algebra skills that you already have and develop a little bit of a feel for working with the decimals. Okay, a shorter problem set this time, again, because there's not like a new algebra skill here that needs to be practiced. So for the first two, the problems have integers in them. 17x minus 33 equals 114, and 2 times negative 5x plus 4 equals negative x. But the answer needs to be rounded to 2 decimal places. 3 and 4, I changed up the directions a little bit. So round to the nearest tenth. Make sure that you're paying attention to that and reading what the directions ask you to do. And that's 2.7 minus 3.6x equals 8.4 plus 23.7x. And then the second one is 6 times 3.14 plus 1.59x equals 12.29x minus 4.37. So pause the video work these out, and then I will unpause the video and you can check your solutions on the following slides. So sorry about my cats. All right, so here's the first problem. This right here looks a little bit like an equal sign, but it's not. I was underlining the second decimal place. So the second decimal place, you're going to look one digit to the right, to the 7, which is going to round the 4 up to a 5. So that's what that is. It's not some wonky equal sign in the middle of the problem. Take a moment, pause the video if you need to, if you did not get the same answer. Second one, the answer comes out to 0.88, really repeating. So rounding it to, again, that's not an equal sign. It's just me underlining it as part of the work. So we look over to the 8. The 8 is, in the 5 or greater. And so it rounds that up to a 9, so 0.89. Third problem, I don't mind working with the decimals, so I'm not particularly likely to clear of decimals unless I have to do something with that equation, where I really don't want the decimals in there. This one, I changed the directions up and said to round to the nearest tenth, which you might have had to go back in the video if you weren't sure, but that means 1 decimal place. So we look 1 decimal place to the right, which is a 0, which means we are going to go down to negative 0.2 or negative 0.2. On the third one, again, pause it if you need to check some of the numbers. If you cleared the decimals out, then your solution might look a little bit different. Everything would be multiplied by a value of 10. And on this last one came out evenly to 2 decimal places. So it's kind of weird to even round that off, but that is what I had put in the directions to round it to the nearest tenth. So you get down to the 8.4, you look 1 digit to the right. That is a 4, which means this rounds down to the 8.4. Don't go down to 8.3. That's like way too far. So this is between 8.4 and 8.5. So you're going to go down to the 8.4, but it did come out evenly. So that concludes pretty much everything that we are going to do on solving linear equations. And our next unit is going to pick up with graphing.